dividing 4a squared plus 7a plus 15 by a plus 3. So our a plus 3 goes on the outside. That's our divisor. And then we're dividing by 4a squared plus 17a plus 15. All right, so what we're going to do is we want to know anytime we have to figure out how many times, because we want to know in a sense really how many times this will go into this thing, right? We always just use the first terms, always. So we just want to know really how many times does a go into the first term here. To figure that out, it's just like dividing, just like here. You know, how many times does 5 go into 6, right? We said one time, right? One whole piece. So same idea, we want to know how many times does a divide into 4a squared? Well, just reduce that. If we reduce that down, that would just equal 4a, right? You subtract the exponents here, right? And you would get 4a. Now, what you do with that is you take that result. Here's what I'll do. That's fine, actually, I'll leave it like that, but maybe, yeah. I take that result and I place it up here. Usually we like to line things up with the like term. So if it's an a term, I line it up with the a term. It actually doesn't really matter, but it just looks better. Now, recall with the long division, when we figured out that 5 went into 6 one time, how did we figure out what goes here? Well, we multiplied that times that and then placed the result here. Same thing. So once we figured out that a goes into 4a squared 4a times, we now multiply 4a times all of this, and then that result goes here. All right? So it's now going to be 4a, and I'll do that off to the side, 4a times the a plus 3. And like I said, that result is going to go right here. So if we distribute that, what do we get? 4a squared plus 12a. Right. Now, so that 5, 1 times 5 is 5, and then we subtracted that away from the top. Same thing here. We need to subtract this whole thing from the top. Now, that negative on the outside, what is that going to do to these terms? If there's a negative out there. Remember how we talked about, it's like when we did subtraction of polynomials, right? There was a negative on the outside. When it was a negative, what did that do to the second polynomial? What can you, not cancel, but distribute it? It switches the signs. That's right. So I'm going to leave it as subtraction because in your notes you should have it as subtraction because it is subtraction. But what you can do is you just kind of make a note of it. Either you make a actual write it in or just a mental note. But this term will become, negative, right? If I distribute there, that'll become negative. And this will also become negative. Okay. So that's my new signs. So I kind of, that's after applying that, right? To both. Okay.
Professor?
Yeah.
Why would you apply that sign, the negative?
Because you're subtracting. So it looks like this. It's like, imagine if you had 4a squared plus 17a minus, and then you're subtracting away from that the 4a squared plus 12a, right? Mm-hmm. We learned that we can always change subtraction to addition. I don't want to switch it to addition here because I want to keep that notation so you know it's subtracting. But you can always switch that to addition. And then we said if you do that, then you got to switch the signs. So it's like plus a negative 4a squared minus 12a because the minus here is really saying plus a negative 1 here. And then that negative 1, if you were to distribute it, it would switch all of the signs. So that's what we're saying here. We're kind of mentally switching those signs. Right, that negative will make that a negative, and that negative will also make this a negative. Okay, so let's do that subtraction now. So 4a squared minus 4a squared, that's going to be 0. So I don't write it. And then 17a minus 12a, 5a. All right. Once we subtracted with the numbers, we brought the 1 down right, then what did we do? We moved over to the next term and brought that down. Same thing here. So now that we're done with this, we move over to the next one and we bring down the 15. So plus 15. And now, in a sense, it's like it starts over. So this is like your new dividend. So now what we want to know is how many times does A, the first term here, go into this first term? Yeah. Because you're combining like terms. So you're just subtracting the coefficients, and then you keep the variable. Yeah. All right. So how did we do that before? Well, we said, all right, if I want to know how many times A goes into 5A, I take 5A and I divide it by A. And what do we get there? 5, okay. Where is that going to go? Above the 15, yeah. Right there. And now, what do I do with that? Well, just like with the 4A, how we multiplied the 4A, right? The 4A multiplied this to give me this. Now the 5 is going to do the same thing. Multiply this times that, and then I put that result down here. So 5 now times A plus 3. That result's going to go here. So what is that equal to if I distribute that? 5A plus 15. And we're subtracting that away from the top. And what is that going to end up equaling? 0, right? Because it's 5A plus 15 minus itself, right? And that's going to be 0. Okay, so what's the answer? 4A plus 5, that's right.